Yeah. No, that was good. So, when I met you, one of the things that you had explained was that today's LLMs, today's models, it's miraculous how far they've gone based on the limitations that there are, as you mentioned before, that they have kind of exceeded expectations in terms of how far the model could go. And some of these things are led to, like you mentioned, the reasoning models was a leap that sort of extended some of those possibilities. But could you talk for a minute? You mentioned the limitations, because fundamentally what you're trying to do, Pathway, what you and your team at Pathway are trying to do is trying to build the next model after LLMs that sort of exceeds the capabilities of LLMs and transcends the limitations of LLMs fundamentally. And so maybe just for those in the audience who don't understand what the limitations are, they probably are going to recognize some of them, but why don't you just sum those up for me, like the fundamental limitations of LLMs that you all are trying to supersede?
Absolutely. So we are building a post-transformer model based on the post-transformer architecture. So we're literally changing the T in GPT, if you wish. And our architecture is called BDH, Dragon Hatchling, kind of sparking a lot of cool memes with dragons around the internet. And the limitations that we have in Transformer, and this is something you all know and you all experience when, like, I'm talking about the audience, is that whenever you have a model, it's trained once. So you get the model and it has a serial number, right? It has a name and a serial number. Because when you train an LLM, you feed it with data and you create something that's called the weights. That's, let's say, you create the brain of the model. But they're created once. It's a bit like a Groundhog Day. Then you have that head, let's say, it's created, and then as you use it, you feed in information that goes into context. But this context is ephemeral. It's like writing something on a piece of paper and just storing it, the notebook, without ever internalizing this knowledge. There's no link between the queries, like between whatever you put in your LLM or how it's being used and how the world evolves, and its weights that were set once at training. And hence we need all those huge, gigantic training runs. Every time a new model release is coming. That's why we need to burn all this compute, because you need to train them once. So this is one. They have like no way to transfer experiences, questions, the things that you feed into them from context to their weights. They're kind of long-term, we call it parametric memory. And they suffer from something that we call catastrophic forgetting. Actually, if you try to do it, there is some sort of like an effect that makes it forget the previous things that they've learned. And this is not something that happens to humans. So if you guys have seen the movie Memento, or the Groundhog Day, every morning the main kind of character wakes up without the short-term memory, without remembering what happened, and then they start leaving sticky notes or tattoos, right, to themselves to kind of know what happened. Right now, the memory that we experience in products and AI products works like those tattoos or sticky notes. And then, of course, it gets larger and it gets better because we do a lot of engineering around it, right? As AI community, there is so much engineering going into it. So we're building large databases. In fact, it's like a database. So you just store things in a database. You have agentic systems that just compress and push around pieces of context, information about your interactions with your model around. And then it gives us an impression of memory, but it's not learning in the way we learn, right? It's a bit like a student who would come to an open book exam without ever having read those books and without ever having understood what really happened there. So unless you internalize knowledge, you can't get further. You're not updating or building frameworks for reasoning that would ultimately allow you to solve new problems. And the second thing is that transformers, so there's the fundamental memory problems in LLM. It's just true. So they cannot, we call it continual learning. They cannot learn continually. They cannot learn with experience. And they have trouble dealing with the notion of time. So memory kind of has to happen over time, right? So they're static. Imagine they're static trained ones. And then, yes, there's a lot of engineering. There's an entire world doing engineering around LLMs right now.
And by that, you mean, Susanna, like the fact that you can create projects and you have sort of some static things that every time you ask a question in that project, it always accesses the same information so that it will try to give you, it sort of will imitate memory a bit.
Yeah.
Or when you can create a profile about yourself in there and you say what you are, what your job role is and background about you. And it's sort of it's overcoming some of those memory gaps by like reading those files every time that you ask a question.
Exactly.
So that those are like the workarounds to this memory problem.
But the difference is between your own family doctor who knows you've known your mom, maybe knows your kids and knows your entire history, where you live and how you eat and how you party, and having somebody who sees you like a different doctor at every time, who reads your file, probably just a recap of your file, right?
Okay.
That's the difference. That's the difference between having kind of internalized knowledge versus a recap.
Yeah. Okay, so that's the first one, is the memory problem. And then you were just about to say the second one.
The second one is with reasoning. Right now, the way we do chain of thought, so we're moving from like pure LLMs, we're moving to the chain of thought system. So that happened with O1, O3. In chain of thought, reasoning happens in language. So thoughts have to be expressed in language, and the model has to work through the problems in language, verbalizing everything. Try to ask a chess player to verbalize his thought process, or her thought process while doing that. It just wouldn't work. That's not how thinking works. Which is something that somehow we actually learned, we discovered. We were hoping, when we started at Pathway, we were hoping that language would get us further with reasoning. But it appears that language already imposes too much structure, or too many limits on reasoning itself. And especially if when you're a chess player, you kind of see a number of possibilities at the same time in your head. You know which ones are less probable. You kind of feel it, and you have a certain shortcuts. I mean, sometimes you find yourself in a new situation, but you find an analogy to something else. So over time, as you work through problems, you create some shortcuts for reasoning that